we learnt in the previous session? We learnt how to represent irrational number on the number line. But that irrational number is square root of some non-perfect square decimal number. Is that clear? Okay, fine. Hope that was easier. Yeah, the concept of how we are getting was a little bit difficult. But the construction work is easier. It is shorter than what we do for root 7 or root 20. Okay. Today, we have missed few concepts, so we'll recall that. The first thing, irrational numbers between given two numbers. We learned how to find rational numbers between two integers, or how to find rational numbers between two rational numbers. Correct? Now we have to find irrational number between two numbers. Alright, first example. Find 3 irrationals between 4 and 7. Between 4 and 7. So children, here you got integers. 4 and 7 are integers, correct? Okay. I'll write in decimal form. 4 point and 7 point. And 2 places of decimal I am going to write. Yeah, nothing is there. So 0, 0, 0, 0. Now you tell me which numbers lie between 4.00 and 7.0. You can say 4.01. You can say 5.10. You can say 6.92. Any number. You see now this 4.01. 0, 0 से आगे लो और 7.00 से पहले लो. There are infinite irrationals between 4 and 7. You can take 4.51, you can take 4.80, you can take 5.33, you can take 5.19, you can take 5.01, you can take 6.99. It is between 4 and 7. You can take 6.037, you can take 6.53. Alright, anything, any 3 numbers you choose between 4 and 7. Alright, let's see. I'm writing the answer, children. Answer. The 3 irrationals between 4 and 7 are. Chaliye. Between 4.00 and 7.00. 4.12, 5.33, 6.09. Okay? Children, these are rational numbers, not irrational numbers. Yeah, non-terminating, ... but non-recurring. How will you represent non-terminating? Say, suppose I write anything I like. 1, 2, 4, 3, 7, 9, 8, 3, 1, 4, 9, 2, 6. कैसे पता चलेगा कि ये non-recurring है? Okay, after hundreds of decimal places, suppose something reoccurs there, you won't know. So to show that it is non-recurring, we have a very simple trick, and it will be very easy for you. See what I do. 0, 1, 0, 0, 1. Now I'll write 3 zeros. 0, 0, 0, 1. Now I'll write 4 zeros. 0, 0, 0, 0, 1. ... What does this show? It is shows non-terminating. And 0, 1, 0, 0, 1. By 0, 1, 0, 1, 0, 1, 0, 1. Then it is recurring. यहाँ को 0, 1, फिर 0, 0, 1, then 0, 0, 0, 1, then 0, 0, 0, 0, 1. So it is not recurring. Yeah, if 001, 001, 001, then we can say it's recurring. But here 10 increases. Let's use similar trick here. 5 2, 5 2 2. I am increasing 2 now. 5 2 2 2. Dot 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 dot. That's enough. From here we realize 5 2, then 5 2 2, then 5 2 2. So it is non dot 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 says non-terminating. And 5 2, 5 2 2, 5 2 2 shows it is not recurring. So this is irrational number. Are you getting me? Chal. 1 5 2, 1 5 5 2. 1 5 5 5 2, 1 5 2, 1 5 5 2, 1 5 5 2. So that shows it is non-terminating to I dot dot dot, and also it is non-recurring. So it is irrational number. Got it, children? Chal. Now let's see second one, and we'll find irrational number between two integers only, and that is 11 and 12. Oh, successive integers. So as I said, okay children, I'll write like this, 11.2 and 12.3. Let's take this type of numbers because we have already seen in the first one integers. Now as I said, 11.2 and at 12.3. As I said, select two places of decimal. So I can put here 0 and 0. Now you choose any three numbers between 11.20, 11.20 के बाद 11.35 आता है कि नहीं आता है, 11.92 आता है कि नहीं आता है, 12.30 से पहले 12.05. So you can select these three numbers. I'm writing the answer. Any three you can choose. The three irrationals, irrational number between 11.2 and 12.3 are. Would you like to select these three or something different? Let's see different. 11.20 के बाद 11.39, then 11.50, then 12.32. You can't take 12.32, उसके आगे है, not between. You may take 2. Alright? Yeah, to show it is non-terminating, you can put dot 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 dot. But to show that it is non-recurring, okay, 3 5 3 5 5 3 5 5 5 dot dot dot. So this is non-terminating, non-recurring, which is irrational. 1 2 1 2 2 1 2 2 dot 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 dot. 0 1 0 1 1 0 1 1 1 dot dot dot. I hope you have understood. Correct? So these are three irrational numbers lying between 11.2 and 12.3. Actually speaking, there are infinite. You can choose any three. Okay. Third one. Find three irrationals between 2/3 and 3/4. Between 2/3 and 3/4. These are two rational numbers. A/B form, P/Q form. And I want three irrational numbers between these two numbers, 2/3 and 3/4. These are not integers. So you will have to divide and convert into decimal form. 2 divided by 3, 0.0. 3 6 are 18, 2 0, 6 are 18, 0. ठीक है children? Alright. चलो. So this is, okay, 2/3 is equal to 0.67 approximately. क्योंकि 6 आएगा. So I am writing 67 approximately. Is that clear? Because I want only two places of decimal. Now next number, that also you will have to divide. 3 divided by 4, 0.0, 7s are 28, 2 0, 5s are 20. Oh, this is terminating. Anyway, 3 upon 4 is equal to 0.75. आपको दो places of decimal चाहिए और वो मिल गया है. Correct? चलिए. Now, you have to choose numbers between 0.67 and 0.75. By 0.67 के बाद 0.68, 0.69, 0.70, 0.71, 0.72, 0.7. So many numbers you will get. Okay. So I'm writing the answer. The three irrationals between 2 upon 3 and 3 upon 4 are, children, 0.67 और 0.75 के बीच कोई भी तीन नंबर ले लो. 0.70 है क्या? ये दोनों के बीच 0.67 और 0.75. Yes. 0.69 है क्या? Yes. 0.67 और 0.75 के बीच. 0.74 है क्या ये दोनों के बीच? Yes. Now you will put dot 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 for non-terminating. लेकिन non-recurring बताने के लिए 1 2 1 1 2 1 1 1 2 dot dot dot. Okay, 0 5 0 0 5 0 0 0 5 dot 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 dot. Interesting, right? 2 3 2 3 2 3 dot 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 dot. So these are irrational numbers. Why they are irrational? Non-terminating, non-recurring. Correct? Okay. So understood? So here you found three irrational numbers between these two rational numbers. See the denominators of rational numbers. Unlike last example we'll see where again we have to find three irrational numbers between two rational numbers. Lekin with like denominator. Let's see. Fourth one. 2 upon 7, okay, 1 upon 7 and 3 upon 7. Please pay attention. You divide. 1 divided by 7, 0.0. 7 ones are 7, 3 remains. 0. 7 fours are 28, 2 remains. Well, ठीक है. 2 places of decimal is enough. Children, because these denominators are like, what you can do? 1 upon 7 value you know, 0.14. Am I right? What is 1 upon 7? 0.14. Now you have to find 3 upon 7. That means 3 multiplied by 1 upon 7. Can you write it that way? And this value you know, 3 into, what is that? 0.14. So you multiply. 14 3s are 42 and 2 places of decimal. So 0.42. So here, alright, 1 upon 7 is 0.14 approximately. And 3 upon 7 is 0.42 approximately. Is that clear to you? Okay? Chaliye. Now you want any three numbers between 0.14 and 0.42. So many 0.15, 0.16, 0.17, 0.18, 0.19, 0.20. Then so many till 42. Choose any three. I'm writing directly now. I'm not writing that statement. Chalo, 0.16 I took one. 0.35 I took. Yeah, it is between 0.1 and 0.42. And I am taking 0.40, which is also between 0.1 and 0.42. Clear? Then I can put anything. 0.52, 0.522, 0.5222, dot dot dot. 125, 1255, 12555, dot dot dot. 35, 335, 3335. Anything, that's how you can write, children. So these are three irrational numbers between 1 upon 7 and 3 upon 7. Children, okay. One more we'll see. Alright. Fifth one. 3 upon 11 and 7 upon 11. Children, see these denominators are like. Forget 3 and 7. 3 upon 11 and 7 upon 11. Forget 3 and 7 for a moment. You divide 1 by 11. So you are finding the value of 1 upon 11. You are finding the value of 1 upon 11. Okay? Not 3 upon 11 or 7 upon 11. 0.0. Not divisible. So still 0 and 0. 9s are 99. Alright? Okay? 1. Finished. You got 2 places of decimal. So this is 0.09 approximately. Chaliye children, what you want is 3 upon 11. So 3 upon 11 is 3 into 1 upon 11. So that is 3 into, what is 1 upon 11? 0.09. This is 27 and point. So here it is. I'll write the value here. 0.27 approximately. That is the value of 3 upon 11. Now 7 upon 11. 7 upon 11 is 7 into 1 upon 11. Now 1 upon 11 value you have found. So 7 into 0.09. 9 sevens are 63 and 2 places of decimal. So for this I am writing it here 0.63 approximately. Chaliye, now you write the irrational number between 0.27 and 0.63. So many numbers. I am writing direct, I am not writing that statement. 0.35, 0.42 and 0.59. Okay? All these three, they are between 0.27 and 0.63. Now as usual, 2, 3, 2, double 3, 2, triple 3, dot dot dot. 1, 5, 5, 1, 1, 1, 5, 5, 5, 1, 5, 5, 5, 5, dot dot dot. 2, 0, 2, double 0, 2, triple 0. That's it, dot dot. So these are irrational number between 3 upon 7 and 7 upon 11. If you are asked to write 4, you may write one more. 0.61. 1, 2, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 1, 1, 1, 2, dot, dot, dot. These are irrational number between them. So clear how to find irrational number between any two numbers, which may be integers, which may be rational with like denominator, or which may be rational with unlike denominator. Alright? Okay. Children, if you don't want to do this, you divide straight away. 3 divided by 11. You will get approximately this. Divide 7 by 11. You will get approximately. So that is another way. Directly divide kar lo. To bhi chalega. Only 2 divisions you have to do. Fine. Now, children, let's go back to what we learned in the beginning of the chapter. Children, please be careful. This is one number line representing 1, 2, 3, 4, 5 and so on. These are natural numbers, set n. Set having the members 1, 2, 3, 4, 5, dot, dot, dot. Alright, let's see the second set, whole numbers. 0, 1, 2, 3, 4 and so on. Whole numbers W. 0, 1, 2, 3, 4 and so on. Correct? Then let's see integers. Zahlan, do you remember? Integers. 0, minus 1, minus 2, dot, 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 dot. 1, 2, 3, dot, 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 dot. Boliye Z. Set. 0, minus 1, minus 2, till infinite. 1, 2, 3, till infinite. This is set of integers. Now you see. How many points are these there on the number line? Kitne points hai? Infinite. Are any points between 1 and 2? 1 and 2 ke beech koi points hai? Hai. So all the points of number line are not occupied by natural numbers. नेचुरल नंबर सारे पॉइंट को ऑक्यूपाई नहीं करते हैं. There are so many points between 1 and 2. There are so many points lying between the numbers corresponding to these 2 points. Alright? So, okay. तो क्या whole numbers? Does whole number cover all the points of a line? जो नंबर लाइन है उसके सारे पॉइंट्स होल नंबर कवर करते हैं? नहीं, नंबर लाइन से एक पॉइंट ज्यादा. The set of whole numbers occupy corresponds to just 1 point extra. यहां 1 से infinite तक यहां एक 0 एक्स्ट्रा है. That's it. चलिए, what about integers? What about integers? Infinite, लेकिन not all points. Not all points, children. Some points नहीं. Between 0 and 1, there are so many still points left. Between 0 and -1, so many points are left. That's why, children, that is next number line. I'm going to write here only now. This is minus 1 upon 7. This is 1 upon 2. If you remember, this one is 3 upon 2. 2 plus 3, 5. 5 upon 2. 5 upon 2. Exactly the center. So like that you will get many numbers. Of which form? A upon B form. Which are rational numbers. Q. Set having the member A upon B. Where B is not equal to 0. And A is any A and B are integers. They are integers. वो कोई भी इंटीजर हो सकते हैं. So children, now see, on the integers I have taken numbers points between -1 and 1, 0 and -1, between 0 and 1, which are of the form A upon B. Children, we have plotted those points, rational numbers. How many rational numbers are between 0 and 1? Infinite. How many rational numbers are between 1 and 2? Infinite. Now the question is, between 0 and 1 there are infinite rational numbers. Are all the points between 0 and 1 occupied, or still some numbers are left out? Children, they are left out. Alright, and those are square root of 0.5, square root of 0.9. Between this, square root of square root of 1. Any number between 1 and 2. Here, square root of 2. Square root of 2 यहाँ आएगा. Square root of 2 यहाँ आएगा. Square root of 5 यहाँ कुछ आएगा. So ऐसे बहुत सारे square roots आ जाएंगे. So children, अभी रेड और ब्लू सारे पॉइंट्स आ जाएंगे. उसके बाद कुछ भी मिलने वाला नहीं है. See this. These are irrational numbers. Blue dot shows irrational numbers. Red dot shows rational numbers. उसके बाद एक भी पॉइंट बचने वाला नहीं है. So all this blue are irrational. All right, irrational number. You can say I, but there is no proper symbol actually. That is root. I have told you. बराबर है? Root of A, where whatever I have explained to you, I am not writing it back. You see, because what we want to learn is here. ये नंबर लाइन पे नेचुरल नंबर्स है 1 2 3. yes. होल नंबर्स है yes 0 1 2 3. इंटीजर्स है yes 0 इंटीजर 1 2 3 पॉजिटिव इंटीजर -1 -2 नेगेटिव इंटीजर yes. क्या रेशनल नंबर्स है 1 upon 2 3 upon 2 एनी नंबर ऑफ फॉर्म A upon B है. The red dots, they are A upon B form. And irrational number है non terminating non recurring है वो blue ones, ये square root वाले. अभी एक भी पॉइंट नंबर लाइन से बचा नहीं है. Children, now all these numbers, एक भी नंबर नहीं बचा, उसे कहते हैं रियल नंबर्स. उसको कहते हैं रियल नंबर्स. एंड रियल नंबर्स का सिंबल, सेट ऑफ रियल नंबर्स इज R. आर में एक भी पॉइंट बचता नहीं है। इस आर में आपको एन भी मिल जाएगा, मतलब नेचुरल नंबर भी मिल जाएगा, होल नंबर भी मिल जाएगा, रेशनल नंबर भी मिल जाएगा, इरेशनल नंबर भी मिल जाएगा, जेड इंटीजर भी मिल जाएगा। उसका मतलब कि आर इज द बिगेस्ट सेट, आर इज द बिगेस्ट सेट ऑफ नंबर्स। You understand? Now you can justify this name of the chapter, number system. So in the number system, on the number line, each and every point can be assigned one number. If you talk about this, you can assign only natural numbers. If you talk about this number line, you can assign only whole numbers. If you talk about this number line, only integers, then only integers. Rational numbers, then only rational numbers. Irrational numbers, then you can take only irrational numbers. But if you consider all points, then this is a set of real numbers. Real numbers. So real number can be any. 2 real number. Root 5 real number. 2/3 real number. क्योंकि वो तो सब real numbers है. Are you getting me, children? Fine. Now, few true or false which are very important. All right. True or false? First, every rational number is a real number. Every rational number is a real number. All right. See, every rational number, तो कोई भी रेशनल नंबर ले लो, ये 2/3 है, ये 3/4 है, समवेयर 4/5 है, समवेयर 5/6 है, ये बढ़ता जाता है. All right, so these are rational numbers. Can you call it real numbers? अरे real number तो कोई भी. So every rational number is a real number. Statement is true. Yes, did you understand? Now, उसका कन्वर्स उल्टा, every real number is rational. Is rational. Let's see. Okay, ये रेशनल है, ये 0, ये 1, देखते जाओ 1 somewhere. All right, this is 1 here, this is 2 here, this is 3 here, this is -1 here. All right, ये बहुत लंबा लिखा था तो यहाँ 2 लिखते हैं और इसको भी यहाँ लिखते हैं -1. All right, then somewhere here you will have √1.2. ये सारे नंबर्स वो रियल नंबर्स दिखाते हैं, रियल नंबर्स. सो कोई भी रियल नंबर पिकअप करो. 2, can you say it is rational? Yes, 2 means 2/1. 1, can you say it is rational? Yes. Can you say 4/5 is rational? Yes. Can you say √1.2 is rational? No. So every rational number, every real number is not rational. So this statement is false. This statement is false. Third, every integer is rational. Every integer is rational. Every integer is rational. We are talking about every integer. So I am representing number line showing integer 0, 1, 2, -1, -2, -3. These are integers. Can you call them rational? Yes. 2 is 2/1/1/1/1/1/1. So every integer is rational. So this statement is true. Now converse. 4. Every rational number is integer. Every rational number is integer. चलिए अभी मुझे नंबर लाइन शोइंग रेशनल नंबर्स. एवरी रेशनल नंबर, आई शो रेशनल नंबर 0, 1, उसके बीच एक्जैक्टली 1/2, उसके बाद यहां 3/4, यहां 1/3, जो भी है. ऑलराइट, ये रेशनल नंबर्स दिखाता है, एवरी रेशनल नंबर. Can you say this rational number is integer? Yes. Can you say this rational number is integer? Yes. Can you say this rational number is integer? No. Can you say this rational number is integer? No. So every rational number is not integer. Alright. So this statement is false. This statement is false. Now if you have found this difficult, I have got one trick. Let me show you. Children, tell me, which set of numbers you learned first? N is the set of natural numbers. That is first we learned. 1, 2, 3, 4, 5, 6. Correct? After that 0, 1, 2, 3, 4, 5, 6. That is whole numbers. W for whole numbers. After whole numbers, 0 integer, positive integer, negative integer. So integers, symbol is Z. After that, rational numbers, Q, and irrational numbers, I am writing it down. Rational and irrational I am writing down. And then finally we saw the biggest set of natural numbers, that is real numbers. Alright? Clear to you? Okay. Now what is the trick to find out whether the given statements are true or false? Very easy. Children, let's see. Every real number, so that is the real number, is an integer. Integer is here. So I have marked them. Every real number is integer. Real number is integer. So from real number you put arrow like this. Every real number is an integer. Alright, done that? Fine. Okay. Next. Every integer is a real number. This time you have integer. Here it is real number. Here it is. Every integer is a real number. Integer is here. Every integer is a real number. Just put that arrow. Next. Every irrational number is whole number. Every irrational number here. Every irrational number is a whole number. That means this. Every irrational number is a whole number. Okay. Then fourth, every whole number is irrational. Every whole number is irrational. So whole number is irrational. So from here towards irrational. Alright. Next. Every real number is irrational. Every real number is here and irrational is here. Every real number is irrational. Every real number is irrational. From real to irrational I have put that curved arrow. Okay. Next. Every rational is real number. Every irrational number is real number. So I start from irrational. I is real number. See that arrow. Alright. Next, every integer is rational number. Every integer, I is not for integer, Z. Every integer is rational. Integer is here, rational is here. So it will be red one. Every integer is rational number. Alright? Okay. And last one, every rational number is integer. Rational is integer. Rational is this and integer is here. So this is alright. So whatever green arrows I have taken, it is clockwise. Green arrows are clockwise. And red arrows anti-clockwise. Red arrows are anti-clockwise. Children, whichever is green clockwise is true. And anti-clockwise statements are all false. But there is exception here. Yahan exception hai. There is exception here. Alright. Let me tell you first now. Let's see. Every real number is integer. Real is integer. See, anti-clockwise. So the statement is false. This is false. F for false. Alright. Every integer is real number. Integer is this. Every integer is real number. Clockwise arrow. Clockwise arrow. So this statement is true. every irrational number is whole number. Irrational, इसलिए मैंने नीचे लिखा है every irrational number is whole number. Anti-clockwise, it is anti-clockwise, so that is false. Now next, every whole number is irrational number. Whole number is here and irrational number. Every whole number is irrational. That is clockwise. That is clockwise. Clockwise is true, but this is false. Clockwise में if irrational is involved, ये exception की बात की ना मैंने. Though it is clockwise, because irrational is involved, the statement is false. Okay? ये आपको ध्यान रखना होगा. Every real number is irrational. Where is real number? Here. Irrational here. All right. This is anti-clockwise. That is anti-clockwise statement is false. Okay? So this will be false. Next. Every irrational number is real number. Every irrational is real. Yes. Irrational is real. That is clockwise. That is clockwise. And this statement is true. इसको याद रखना. This is कोई भी irrational वाला statement आए, it is false except this. Irrational is real. Yes, true. Rest all statements regarding irrational would be false if they are compared with any set of numbers. Okay? Next. Every integer is rational. Integer is here, rational is here. Integer to rational, clockwise. Clockwise is true, so this statement is true. Every rational is integer. Every rational is integer. This is anti-clockwise. Anti-clockwise statement is false, so that is F. Maybe you got messed here because of lot of arrows. So we'll see one by one. Okay? First we saw set of natural numbers, whole numbers, integers, then rational numbers and irrational, rational and irrational, and then real numbers. Now see one by one. Real number, here it is. Integer, here it is. Real is integer, so from real you take integer. Alright, forget this now. Is it anti-clockwise or clockwise? Anti-clockwise, anti-clockwise, false. Here it is. Okay, I remove this now. One by one, it will be more easier for you to see. Chaliye. Every integer is real. Integer, here it is. Real number, here it is. Integer is real. So from integer, you move towards real. ये ऊपर ही arrow करना है, नीचे नहीं. Okay? Now, what is the direction of arrow? Is it clockwise or anti-clockwise? Clockwise. Clockwise, the statement is true. Yeah, but in that, if irrational is involved, ये पीछे जहां ये arrow है, वहां irrational होगा, तो statement is false. Okay? चलिए. So that exception is here. So this statement is true. All right. Let's see the next statement now. Well, every irrational, here is irrational, is whole number, here is whole number, irrational is whole. वैसे भी anti-clockwise, so anti-clockwise is false, so the statement is false. Got it? Chalo. Next. Every whole number is irrational. Whole number is here and irrational is here. Whole number is irrational. Hey children, this is clockwise. But जहां arrow है, वहां irrational है. So this statement, though clockwise, is false because of that exception. So this is false. ठीक है. Let's see the next statement now. Every real number is here, is irrational. Irrational is here. Real is irrational. Real is irrational. Anti-clockwise. False. Right? Chaliye. Let's see the next statement now. Every irrational is real. Irrational is here. Real is here. Irrational is real. Every irrational is real. It is clockwise. Clockwise true. लेकिन irrational is involved. So check whether that exceptional case is there or what. जहां एरो है वहां तो irrational नहीं है ना, नहीं है. So this is true, ये exception में नहीं है. So every irrational is real. That is true statement. चलिए, so that is how you got true statement. Now next, every integer is rational. Here is integer, here is rational. Integer is rational. This is clockwise. Clockwise is true. ये exceptional case नहीं देखना है क्योंकि irrational numbers are not involved. So every integer it is true. और every rational number is integer. उसका converse rational is integer. ये anti-clockwise. Anti-clockwise the statement is false. I hope you understood, children. All right. So here we end up our chapter. You will get assignment for your homework. Okay, children. And let me tell you, you give me your views regarding the videos. All right. Like I had complaint about the bad quality of video. It may be, children, because the weather becomes dull, cloudy. That time there is variation in the light in the room. All right. Anyway, there are solutions to it. I look forward to it. All right. Okay. So I'm giving you my WhatsApp number 9879338663. So if you have any queries, you WhatsApp your message to me on this number. Text your message to me on this number. Okay. Totally we have seen 13 videos. All right. If in any video, if any issue is there, if you have not followed any concept, please message me on this. All right. So that in the next video, I can solve all your difficulties. Okay. There may be other way to teach you. So I can use that method and then maybe you will understand that. So by teaching by one method may not always reach you. So to reach you, I have variety of methods, but I should know what are your problems, what are your issues, what are your difficulties. Once I know your problems, they can be solved very easily. So any message you can put here. All right. Yeah, sometimes I may have been very fast. You can text the message. Sir, were the wild dogs chasing you? You were moving so fast. Any kind of message, they are most welcome. I have to take every message positively. All right. What? Yeah, if I was fast, I was. So I should know where I should slow down. In which concept I should slow down. So please send me your views on this number. Is that clear to you? So that's all. Your first chapter is over. I'm going to give you assignment. Whatever difficulties are there, you can text me here. So in the next video, I'll solve your difficulties as well. So goodbye.